Hello, my friends. I mean you. Yes, you.
Data of every description will pervade our consciousness. Holograms projected beneath our eyelids.
Welcome to the DCC Museum.
Hi and welcome back to the DCC Museum. Today we're visiting beautiful Wolverhampton in the UK, and the reason for our visit here is to visit Mended Mark.
Hi.
Mended Mark is a specialist, and we need one today because we are bringing him a prototype, at least a one-off, we think, made by Bose, by Delco, unique combination, MiniDisc and DCC. It is not working. We have tried to get it to work for the past 2 years, but today Mark will go and give it a shot.
Well, you can see this is a Bose branded double DIN car head unit, and a bit special, it takes mini discs, which I've heard of, and digital compact cassettes, which I haven't heard of, not till today. We see the nameplate, you can see prototype material, and without any doubt it was made in 1995. And around the back of this thing there's an aerial socket and a big plug. I don't recognise this connector whatsoever, but luckily Ralph's brought one with him. And here's the connector, like I've never seen before, but luckily it's got all the cables already in there, and they are actually labelled up with what they do, which is very handy. I'm only going to wire up the battery supply, ignition, and I think the lights for illumination, see if it does anything. We'll take a punt. It actually runs on 12 volts like the cars over here. Put the positive connection there and the ground here, nice and convenient. Oh, to give it some juice. Well, what's it doing? 60 milliamps, that's not too bad. Oh, we've not even turned it on yet. What's it doing? Well, we've got no action here, nothing. Power, no. I'll be honest, I don't really know what I'm doing, but there's not much life in this. Well, there's nothing to see on the front. Is there anything to see in the top? Well, there's some sort of cassette mechanism. I assume this is the DCC mechanism, but like I say, first time I've ever seen one. Don't suppose you've got a digital compact cassette on you, have you, Ralph?
I actually do. This is what it does. This is all it does.
Well, it looks alright to me.
Yeah, unfortunately now it doesn't come out until you turn the power on.
Oh. Well, there's no manufacturer's information to help us here, no service manuals, no drawings. I think all we can do is take this apart. Now I'm going to go with the screws at the top that I can see. There we go. There's bound to be a cable under here, I don't want to break it. Oh, it's not too bad at all. I'm expecting to find things like a 5-volt power supply and probably some voltage boost circuit, which this maybe is here. But yeah, at this stage I'm not sure what's going on. I'm not sure what's under this tin lid either. At this stage, not important. Well, now the cassette mechanism's out of the way, we'll see if it still behaves the same. Same story so far, 50 milliamps. Well, there we go. I don't know why it's done that. It's lower current though, 650 odd milliamps. I think what might be confusing the issue is I'm powering it up completely. So you've got the permanent battery connection for the memory, also the ignition, and this is for the illumination for these lights. So I'm going to unscrew these because I think I'm confusing myself. We'll try it again without the main power connection. Oh, still 50 milliamps. That's not great. Oh, it's exactly the same. Well, that's no good. That shouldn't even be on. That is going to flatten your car battery in no time. So something in here is burning up 7 watts of power whilst it's turned off. That's very interesting. Let's see if we can get anything hot with the thermal imaging camera. And oh, straight away, yeah, something's a bit warm. It's not terrible. 40 degrees, and that's the amplifier chip. Well, that shouldn't be on now, but it is. But nothing's particularly hot. That's just reflections you can see in there, taking a notice. Yeah. I'm going to have a look what's under this tin box. Could be hiding a lot of things. Oh, and it is. That's a lot of silicon, that is. We got 1, 2, 3 microcontrollers, each with their own resonators, so they each got their own clocks. There's going to be a lot of communications going on this. And I suppose if they're not all talking, it's not going to be happy. We'll see if they're running hot. Looking at these microcontrollers, yeah, they're not even warm. Yeah, barely warm. It's certainly not losing 7 watts, put it that way. First of all, the fault finding is checking the supplies. We've got some sort of, what looks to be some sort of switching regulator here. It's got 5 legs. I don't know what it's for, and I don't recognise its model number. It's an M47AG. Never heard of that either. We'll check each leg one by one very carefully. 7.4 volts. Okay. 0 volts. Also 0 volts. That one's connected to ground. This pin here, 11.83. That's going to be the main supply, and this last leg, 8.7. I'll be honest, I'm not sure what that's trying to show me. I don't know what it's for. Also got this device at the back. Yeah, another part number I don't know. It's an M44JR. It's not a regulator, I know. It's not like a 7800 series. I'll check if we can find anything there. Right hand leg, that's normally the favourite. Ah, 5 volts. Something sensible. Time to connect the oscilloscope. And the power supply ground, I'm going to put that in there, just for my convenience. There's loads of test points around these chips, so I guess pretty much every pin's sort of accessible. I'm going to have a poke around, see if I can see any life in this. This is around the slave chip, and nothing. Everything's at ground potential. Well, there's something different. 5 volts on that pin. And here. Another 5 volt rail there. I'm expecting to see some sort of data flow between these chips, and so far this isn't looking very encouraging. I think this is a crystal or some sort of resonator. We'll see what we've got there. Go on either side of these little caps. Well, there's some life. We've got a clock signal. So that's about 16.6 megahertz. Yeah, that's quite speedy. Well, it was in the 90s. And this is the crystal for the master chip here. And that's the same. 16 megahertz. And I spy another one here. 4 megahertz. Lovely. I'll have a snoop around the master chip as well. I need to find signs of life. We found a 5 volt rail. That's about all so far. And another one. I'm not going to lie, this could take a while. Oh, I found some data. Oh, look at that. Signs of life, this is good. And more here. This is quite encouraging. I like my chips when they're not dead. So no display, no signs of life at all. I think we've got to look at the front panel. From what I can see, there's only this connection to the front panel, so that should be quite easy to check through. So the knob's got to come off as standard. Looks like the front panel's held on mainly with plastic clips. Sort of gently tease them off. Don't want to break these prototypes. Let's pry it off gently. It's off now. Let's check for signs of life on this ribbon cable, see what's coming in this front panel. Oh. This isn't what I expected to see. This is like mains interference. But nothing else. I reckon it's lost to ground. That's what you get when there's no ground. Just check for some ground continuity. Anywhere on this. There's none. Should really check this ribbon cable out. See if I can disconnect it. Poke the little tabs up from behind. It's not the tidiest ribbon I've seen, I have to say, but it feels pretty sturdy, to be honest, even if there are some bends and little tears. I don't think this is it. I've actually never seen one of these broken, unless someone had torn it in half, but to be honest, this will take some tearing. I'll take this front panel off so I can get a bit of a better view of what's going on. You can see the MiniDisc player here. Nice bit of engineering there. Looks like this just lifts off. Yeah. This thing seems to be a modular design and there's cables everywhere and they're quite short. I think the best bit to do is take all of this out of the chassis. Well, I don't think there's any screws left in this thing, so it should all come apart. And I think this is maybe an inverter board, probably to power a vacuum fluorescent display. This is the RF tuner module, I think, because there's an aerial socket on it, to be honest. That's why I think that. It's a bit trapped in here. I think, yeah, don't look. I've got to do something unpleasant. That should expose a bit more board for me. I've got some plugs. I'll unplug those before I tear them off the circuit board. And a little fan connector there. Well, this is one of the sturdiest mini-disc players I've ever seen. For a small thing, it's quite hefty and well made. Oh, what's this I see? This looks like some sort of stacker system. Oh wow. This actually puts multiple mini-discs in there. That'll be a mechanical marvel and I'm keeping well away from it. This is all full of Sony branded chips, so I think this is all mini-disc related. Although that looks a bit burnt. Let's check it out. There's a bit of a lump in it. We should measure it. I think it's a transistor. And it measures like a transistor. Oh, look at that. It's obviously had some distress in its time, but there's nothing wrong with that. There's an identical one next to it. And that one measuring identically. Yeah, we'll park that one for the moment. To isolate the problem, I'm going to power up just this main board with the tuner, only because I can't remove it easily, but it shouldn't be turning itself on. Oh, the same 50 milliamps. So far no problem. Oh, spoke too soon. I'm still drawing quite a lot of current. It's definitely on this thing. Well, it shouldn't turn on until you press the button on here, and that is mounted on the back of this. So I wonder if there's something wrong with the switch. Although it's not connected, something wrong here I reckon. The switch contact block's on the back end. It's got 3 terminals, so it'll be a normally open, normally closed affair. So for the middle will be the centre. Yeah, this is the normally closed part. And from there to there, press the switch. Yeah, that's fine. Oh. Yeah, it's not this. We trace this through these end pins here. When you press it on, are actually connected to ground, which is the first pin there. So the sensor pins come through here and go to pin 4. So if I measure the voltage from pin 1 to pin 4, we've got 5 volts, so yeah, that's how you turn it on and off, I'd have thought. Put that back in there just to check. Just holding the power switch in now. Yeah, nothing happening. I removed the front panel circuit board off this so I can get a better view of what's going on inside. These nuts are a funny size. I don't have anything that fits these. There's not a great deal to see on here. Lots of bulbs, I'm sure they work. Got a vacuum fluorescent display. We've not seen it come on, but something we do know, that there should be some sort of AC voltage across the heater here. Otherwise the display will be dim at one end. I do see a display driver or maybe a microcontroller under there. I expect it's another one with no number that I recognise. Just unplug that because it's in my way. I'm going to reconnect this ribbon cable. I think it was that way round, wasn't it? Oh. Hang on. I don't know if you guys will make this out on here, but the contacts on this are actually on the top side. And the ribbon cable went in that way. Well, that'll explain why the ground was missing. Well, we'll try this in the conventional way up. See if it behaves any better. Let's see how it behaves now. Same 55 milliamps as before. Is it going to turn itself fully on? Oh, look at that. 1 milliamp, no milliamps. This is more like it. Well, no milliamps, that's a good low current draw. So we turn it on. Oh. You have to hold it. Oh, why isn't it turning on? What's up with this now? We got the 5 volts there. On this pin, wasn't it? Well, there's nothing there. Yeah, ground at both pins. Well, that'd be why it doesn't turn on then. I'm going to probe these pins again, see if we've got any action anywhere. And nothing. Looks grounded though, that's a good thing. Oh, we got 5 volts there. Well, that'd be a good thing. That's like the standby voltage with a very low current draw. Yeah, a load of 5 volt connections. What I'm finding hard to understand is it turns itself on without the front panel on, but it won't stay on or come on with the front panel connected. It's very weird. If I unplug this switch, because it basically does nothing, I'll also unplug the front panel, see if it'll come on. It's turned itself back on. How strange. To make sense of this, I need to take this display off so I can get to this chip. Let's see if this chip I can get a data sheet for. There's a lot of pins to unsolder. Oh, I do love a vacuum fluorescent display. Look at that. They're a piece of art, they are. Beautiful. There's 2 chips under here, they're both Oki branded, and if you Google the part numbers, you get a data sheet for a laser printer. So, yeah, no joy there. Looking at the way this is laid out, nearly all the connections are fanned out to the display itself. Some must go to the keypad matrix, surely. But more importantly, do any of them go to this connection here? And I measure the stuff that comes onto this socket when it powers up. I'm also going to put this inverter board back in, just so we can see if that's working. I'm going to call this end of the plug pin 1, I'm just going to go along it. So pin 1, we got nothing. Pin 2, also nothing. Pin 3, nothing so far. Pin 4, pin 5, got a bit of volts there, about 2 volts. Pin 6, nothing. Pin 7, we got data. Data is coming out that pin, this is great news. Pin 8, more data again. Pin 9, the little pulse. Pin 10, more data. Pin 11, nothing. Pin 12, we got 5 volts there. Pin 13, 5 volts again. 14's ground, 15's ground. 16, oh, some high frequency stuff. That's the AC waveform for the vacuum fluorescent display. The inverter's working. Pin 17, oh, same again, must be the other side. Pin 18, 12 volts. Pin 19, pin 19 goes off the scale. Wow. Put the timestamp probe on that. Oh crikey, that's about 50 volts. Well, that's what you need in a VFD display. And pin 20, ground. I have to pull out from the ribbon cable where those data connections go, because they for sure go to this chip, but where? Probing from pin 7 around the chip, trying to find a leg. Oh, found one. There it is, there's 7. And pin 8, it's on that row again, none of these. What's that pin there? And pin 10, oh yeah, there it is. I've got it connected up again and the power on, and it's drawing just a few milliamps. But I have checked something. We've got a clock signal there. This is at least alive, even though we got no data coming on these pins. What is throwing me off is the complete inaction of this power switch. And I'm just checking again, pin 4, which should be the 5 volts, it's not there. We've got no volts there at all. So it'll do nothing. I don't know where that voltage comes from. So I'm checking for continuity between pin 4 to wherever it goes. I mean, straight away it's right next to it on that pad. The other side of that wire just goes here, and it's not connected to anything, so it must go to a middle layer in this board. I'm just sort of brushing around, see where else it's connected to, especially around this socket, because if this goes to that control board, especially that chip, that could be part of the problem. Oh, we've just found there, here we have a 10k resistor going to this point here. So what's this? These are all joined there, so I think these are pull-up resistors. So where's that come from? So I'm just going to sweep around here, just hoping, with pot luck, to touch against something that's connected to this power supply rail. Oh, what was that? It's connected to a capacitor. That's not that unusual. The top pin of that chip. It's a Phillips chip with a number I've never heard of. That's not a conventional thing, but power supply on this top corner, that's quite conventional. I doubt that's some sort of output, but I can't tell. I don't know what that chip is. I will check this tungsten capacitor out just for shorts, and it's fine. And to be fair, the thermal imaging camera would have picked up on that. That's a red herring. Unfortunately, I don't know where to turn next for this, I'm afraid. I think this one's beat me.
So, not every story ends in a happy ending, but it was awesome to visit here. It was an honor to see you work.
You're welcome.
And the story continues, because we hope that when people that know more about this machine contact us and could get us a schedule or some pointers on where to look next, we might be able to get it working in the near future. And as it turns out, the story does continue. When Mended Mark posted his video, there were quite a few comments under the video, one of them leading us to a GM forum. On that forum, we were able to meet Craig, and Craig has been working at GM for nearly 40 years. He told us some valuable information about this radio, that although it was labeled 1995, it was actually meant for a 1996 Deville for the Japanese market. And because of this later technology, just adding power is not enough to get the radio started. It will look for two things. The body control unit, the heart of the car, will inject the VAN number, which is the registration of the car, and that will enable it to power on. After that, of course, it looks for the code for the anti-theft, which also needs to be reset. So he told us, you need to find a body control unit and a tech tool. Then we reached out to one of our Patreons, Gary Miles, who is a GM radio specialist, and he's currently working on it, finding the body control module so we can build something to reset this module to be working here at the museum. At least then we know we have all the tools to get it powered up and see if there's anything wrong with it. But for now, we have to admit defeat, but it was still awesome to visit here and to make it a nice day. Thanks for your hospitality.
You're welcome.
Thanks for your wife, for the awesome cooking. Thanks for watching. See you next time.